All right, Greg. So we didn't get to see each other at PRI because we were both really busy in our booths.
Yep.
So you didn't get to see our really fun new toy.
Oh no, but I got reports. I had plenty of people coming back telling me, hey, Lake says you're gonna love this. And they were not wrong. Oh my God. Tools. You know how much I love tools. You know how much I love data. You know how much, I mean, how many other people geek out on the profilometers like I have, and this is a profilometer on steroids?
Yeah. Right. Yeah, this is like taking a profilometer to a whole new level. But the great thing is, it's not like making it more advanced so that it's harder for someone to understand.
No, not at all. It's making it easier. Like,
you're
just showing me this, and I'm like, oh, that's how my brain already did this. Like, and now you're showing me, like,
okay, let's just go ahead and be honest. Probably the biggest challenge, the hurdle for someone to use a profilometer isn't the money, really.
No.
Because people spend a lot more money on tools. If we're being honest, right?
Oh.
Your Maximizer box with all that stuff in there is way more money than the profilometer cost.
I mean, let's be honest. For my tiny little home magazine shop, I've had to stop myself because I'm like, you're gonna measure 2 blocks a year. You can just drive to Total Seal and use it. Like,
yes, you can.
Like, do not buy a profilometer, stupid. Because it's attainable. I could do it. I absolutely could.
Yeah, it's not out of reach money-wise.
No, not at all.
But the challenge for most people is now you're having to learn this new language. You know, RPK, RVK, RK, and all. How does this? My block grit or the hardness of my block, the grit of the abrasives, the process. There's this whole learning curve that's intimidating to people.
Yes.
Well, here's the reality. Those numbers we talk about, RPK, RVK, RK, those are the numerical representation of the trace. Because this thing, like you mentioned, stylus, is no different than a record player.
Yeah, it just drags across the grooves and it maps
put the needle on the record, right? And it drags it across, it creates that picture.
Yep.
Well, the problem with the profilometers of the past is that the picture of the trace auto scales. So it's really difficult to look at one trace versus another, used block versus a brand new block, and know it and trust the picture because the scale changes. So it can lie to you. So the only thing we can rely on are the numbers, which is a numerical representation of the picture.
The averaged numerical representation.
Ooh, very true.
That's kind of a scary number because outliers can change the average. Average can lie to you.
It's gray. It ain't black and white.
Yeah, it gets into the thing where you have to, when you have one thing that you can see, you have to trust that. Yeah. Even if you know that can be fooled, you have to trust it.
Now, with software that can run the profilometer, we have a fixed scaling, and now you can trust the graph. Because the graph is the actual truth.
Yeah, and not only that, but in the software, you have your ranges.
Yes.
There's no, I know I need to be within, 14 to 24. No, you need to be within that range.
Right.
And if there's outliers like these guys, they don't affect, because you can visually see that and now go, okay, I've got a couple deeper valleys. There's nothing to worry about because there's only, literally there's 4 deeper valleys right here of how many different traces, how many ups and downs. So it's like, my brain says, I'm going to disregard those because they're not hurting anything.
Right.
However, those do change numbers. If you want the numbers, they're still there.
Yeah.
But those numbers definitely change your average number. Yep. But you're getting a 3-dimensional picture now.
Oh, and you get the material ratio curve, which is that whole representation. So we have the trace plus the ratio curve. It lets you see, did I actually achieve that transition from a flat on top to the valleys underneath? Because if it's actually plateaued, then it's going to be basically 2 different surfaces.
Yeah.
A flat surface up here to run on,
and then
these valleyed surface down here to retain oil.
And this graph right here is so cool.
Oh, if it has that.
Explain this to me, and it's just, it's something that you don't even think about until you think about it. And now it's there Full color.
That distinct curve lets you know that there's two different surfaces. When you saw the one I showed you earlier that was more indistinct, it goes like, maybe, and then it changes his mind. And you can see from the trace that there were 2, 3 different things going on. Like, well, it's one way up here, it's different right here in the middle, and then it's different down here. It wasn't just 2 distinct surfaces. You can see it.
Yeah.
Wait, and then we've got the best part of it all.
Yes, I will gladly admit to that being the best part.
So we have the profilometer, which we've always known, talked about for years. This is great. Meet the USB microscope. This little guy right here can zoom in to 270x magnification. Like literally this right here is a chunk of alusil cylinder from a Porsche. I can put this on this block, I can focus it, and you can literally see the silicon particles, because alusil is aluminum with silicon nodules throughout it. You can see that black and white on the screen.
It's insane. I mean, the first practical application is you guys aren't going to have to print any more of your crosshatch angle cards.
No, you'll never have to have one of those ever again, because this lets you see and actually shows you on the screen what's the crosshatch angle. Like this right here is 45 degrees, because it will show you what it is.
Well, let's be honest, 45.3 degrees, because it's CAD CAM measuring your angles.
Yep.
Because it sees where the lines are, it draws it. And
you can change if you want the included angle, or the individual angles. You can see it all, whatever you want to see. It's right there in the software.
As we're digging around in the test block behind me, you can see where, okay, this one's 30.1. Well, up here it's 32.2, and you move it around the block, and it's just sitting there measuring it the whole time. Yep. It's not like you have to click it and then draw lines yourself. It's doing it real time. It's so cool.
And you can literally go from the top of the block to the bottom of the cylinder, and you can see the variation, and you can see when the head spins and it flattens the crosshatch angle out.
Yep.
And by the way, we've tested this a few different folks, so they'll tell you, with your hone, if this pulley and this gives you this crosshatch angle, this will tell you what it really is. Because I've seen it, they say, that's just 45 degrees. You put this in there, no, you're 59.5. I mean, that's what you really are. And by the way, at the bottom, you're 16, because it goes flat,
Well, I can already see fun challenges with this, like when I brought the flex hone down here to see who could get the most consistent hone. And I mean, I can think of all sorts of games, but the usefulness of being able to verify your crosshatch, because that's your ring speed. That's I mean, that's not something you need to guess at.
Let's go beyond this, because as cool as this is for cylinder bores, and my God, if anyone knows me, you know that I'm in love with this thing. It's fantastic. This is the greatest thing ever. But this will measure anything. You can measure a cam lobe, you can measure lifters. You want to look at your push rod tips? You can. Whatever you want. Deck surface. This measures any surface and quantifies it in a way you've never been able to do it before.
I mean, let's think about this. Let's talk about cam lobes. You can see stuff. You can see where that you couldn't see with the naked eye. 270x.
Yep.
So you can see a lifter wheel.
Yep.
You could potentially identify failures before they're going to happen. And
I mean, this little specimen card that we were able to pick up that shows different surfaces, milled, ground, turned surfaces.
Yeah.
We were playing around with it. You can see the torn metal. You can see whether or not it's neatly, cleanly cut, or if it's all smeared and torn. So yes, I mean, for failure analysis, this is an incredible tool for looking at those failed parts. I mean, my God, if you couple this with used oil analysis, there's nothing you won't know about a failed engine. I mean, you could literally diagnose failures in a way you've never been able to before by looking at that used oil and looking at these parts with this. I mean, it's a game changer. And the reality is, all of that is way less than a Pro Charger.
Absolutely. And think about it too. MLS gaskets become tenfold more popular in the past 10 years.
Oh, of course, yes.
One thing that has always scared everybody is that they require a specific finish.
Correct. You can know without a doubt.
Like no ifs, ands, or
without a doubt in like less than a minute.
Yeah, and you say now you know your block and your head, good to go. They're good to work with a MLS gasket.
Did I mention you can save all this on the laptop? So like my phone reel, the photos on my phone are nothing but profilometer pictures from all the blocks I've measured, all the stuff we're doing all the time. So now I can actually have like pictures of my kids and my family and stuff on my phone and not be weeded out by all the profilometer pictures, because I can literally save them in here, and then you can save and drag and drop all your files. So you can literally compare, like right now on the screen, we've got a run and an unrun cylinder of the same hone. And you can literally see the difference between run and unrun. So you can save everything right here. I can email it to you.
So you could track the life of an engine.
Yes.
You could track a rebuild.
Yep.
You could track a failure. You could, if you started with a bare engine, brand new project, you could track literally, not just track,
cylinder
quantify
board, deck finish,
for its entire life.
journals, what do you want to?
Oh, see, that would, I didn't even think about like journals,
This on a crank journal? Come on, give me a break. It's awesome. And it's not incredibly expensive. I mean, this whole setup, turnkey, out the door, delivered, is $6,000. It's set up. I mean, that's the software, the laptop, all the stuff. Literally, all you do is take it out of the box, open it, and use it.
Now, I can be honest and say this. I was just going through Amazon last night because I needed to check for some stuff. I spent more than that on Amazon this year.
Yeah.
I mean, maybe that's saying something bad about me and my spending habits, but I'm saying that's not an unattainable number.
In the realm of the world we live in, with the performance parts that we buy and what stuff costs, $6,000 for something that will last a lifetime is really affordable. And the amount of information you're going to get from it and what it could potentially save you by preventing a failure will pay for itself.
What's it cost the first time a lifter goes and wipes out everything down path of it? If you caught that.
Or this a bore finish that's wrong. Something got messed up.
Or you find 10 more horsepower in your bore finish.
Right.
Who wouldn't pay, I mean, seriously, in serious competition, who wouldn't pay $6,000 for 10 horsepower?
Or 15 or 20. I mean, literally, we had a customer
I don't want to
recently,
put words in your mouth.
Well, I know, no. So we had a customer at the PRI show come up to us and talk to us about his experience this past year with bore finish. And from where they were before they started changing, they to hit the numbers, they were able to hit the numbers actually, but the way they went about doing it was actually creating a torn and folded and smeared surface. So the numbers looked right, but the actual geometry was really wrong because they were.
This is where averages can bite you,
right? Because they were running basically, too much pressure, too much speed, and they lost 50 horsepower. And they were really pissed off, which rightly so, because you went way backwards trying this new finish. Worked. Changed the abrasives, changed the process, changed feeds and speeds.
Yeah.
Same numbers, but now that surface is actually clean and neat, and now the board geometry is right because it's not
all mushy
all around anymore. They gained 20 from where they had left off.
So they picked up their 50.
Yep, and gained 20 more. 70 horsepower swing on an 850 horsepower engine, just changing surface finish.
I think we're starting to realize, just as a whole.
Would you pay $6,000 for 70 horsepower? I'm pretty sure a lot of people would pay $6,000.
I think I have
for 70 horsepower.
I think I have before.
Well, I'm pretty sure I have. And so this tool, because you can see torn and folded, and you're not relying on the numbers anymore, this gives you that ability to get to that level and maintain that. So that if you go from a gray cast iron block to compacted graphite or something like that, you can maintain the correct type of surface so that you don't end up losing 30 or 40 or 50 because you made a mistake.
I mean,
unwittingly made a mistake.
Yeah, I mean, even batch to batch. Some blocks can have a hardness rating, that'll
front to back.
Yeah, what? 30?
I mean, we've seen people, hardness of the block vary 20 Bernal front to back.
So 30 between blocks wouldn't be a...
Well, it's funny. One of our guys was in a shop 2 weeks ago, and he stopped in his gray cast iron block, and they had sleeved 2 cylinders. So they honed the block completely. Mm-hmm. They checked all 8 cylinders. The surface finish on the 2 sleeves was completely different than the rest of the block.
Because it was a completely different hardness.
Right. Even though the same hone, same operator, same everything.
Well, I mean, that's the same thing. If you're cutting carrots,
yep,
and you apply that exact same pressure to Play-Doh, it's going to cut differently. Yep. I mean, that's a bit extreme, but I mean, it's hard versus soft.
And then that led them to, okay, well, there's 2 other blocks over here in the shop we just did. One's got, hard Darton sleeves in them, mm-hmm, and this other one's a different, big block that's like high nickel block. Sure enough, they all honed the exact same way. Every single block was different in the surface finish, even though the same operator, same abrasives, same coolant, same everything, because of that material hardness made that variability. This lets you see it and not just fine tune, but truly perfect your recipe so that you get the maximum performance and durability. Because I'll tell you this, it's not just about making more power, it's about durability of that power. Because if you really get a good, clean surface, that surface will live. That way it's durable power that lasts and runs and runs and runs.
Yeah.
That's really the key to this. Isn't just, hey, I'm going to spend some money and I'm going to learn some cool things. It's a useful tool, but I'm going to gain some power. Well, you may also gain a lot of durability by being able to fine tune your recipe.
I mean, imagine being able to do this on every block, right? So it takes, I mean, we ran a trace. It took less than a minute.
Yep.
And it's easy to understand. It's actual information. You got your crosshatch angle measured. You got all this stuff measured on each block. You know if there's a problem before it goes out the door.
Oh, absolutely.
Like, oh, oops, I found the problem at 9,000 RPM in the burnout. Oops. Like,
or if the fuel washed down the wall and killed all the oil film, and so now the cylinder bore is wiped out, you'll see it.
Yeah, you'll be able to troubleshoot.
Yeah.
That's...
Well, it's the old saying, right? Seeing is believing.
Yeah.
Buddy, this system right here lets you see.
Yeah. And honestly, it's so easy to understand too. I mean, like you've got visual representation of peak and valley. Like it's not...
There's no guesswork.
Yeah, there's no guessing. It's like, oh look, everything is in the proper valley. Oh, nothing goes above peak, everything's within spec. Oh look, here's the shape of the peaks.
Put it this way, you'll never have to wonder what those numbers mean ever again, because you're going to be able to see it,
know it,
and control it.